Hello students and welcome to this video lesson. Today we're going to learn the second day of linear programming, specifically word problems. So our objectives today will be able to determine the variables, objective functions, and constraints for a linear programming word problem. We'll be sketching feasible regions and finding vertices, and we will know that one of our answers occurs at the vertices and we'll be able to decide which one. So I just wanted to start with some of this vocab. There's a lot of vocab on this page. So what is the feasible region? Well, we talked about this yesterday. This is the shaded region where every point meets all of the requirements. Now, we mainly are concerned about the constraints. The constraints are the inequalities that define this feasible region. So those are the ones that we sketch in, and then we use the vertices of that in order to find our max and our min. So that leads me into my objective function, which is just the goal. Our goal is always either going to be to maximize or minimize a value. So remember that there are notes in your packet today, so you should be following along in there. So we have two examples, and I will just read the first one to you. So it says ice skates. A factory manufactures two kinds of ice skates, racing skates and figure skates. The racing skates require 6 work hours in the fabrication department, whereas the figure skates require 4 work hours there. The racing skates require 1 work hour in the finishing department, whereas the figure skates require 2 work hours there. The fabricating department has available at most 120 work hours per day, and the finishing department has no more than 40 work hours per day available. If the profit on each skate is each racing skate is $10 and the profit on each figure skate is $12, how many of each should be manufactured each day to maximize the profit? Okay, so it looks like there's a ton of words there and it's really scary, but we broke it down for you because we have this template, and this is how we're going to do the homework too. So there are 2 examples for the lesson today and 2 in the homework. So it's not that bad. So let's answer this first question. It says the objective is, are we maximizing or minimizing? So I love my highlighting tool. My highlighting tool right here says we're maximizing profit. So I'm just going to write we're doing a maximize. Okay. Next, it's going to ask, what are my 2 variables? Well, if you read the sentence, I'll start highlighting again. First, we have racing skates, and then we have figure skates, right? Those are my 2 variables. So I'm going to call this one R and this one F, if that's all right with you. Okay. Now it says write an expression for the objective function. So remember, the objective function is our goal of maximizing. So let's see here. We have each racing skate is $10 and each figure skate is $12. We're trying to make a profit on them, right? So my profit equation, it's actually an expression, is going to be 10R plus 12F. Because it's how much I'm getting per racing skate plus how much I'm getting per figure skate, because I'm trying to sell both. Okay. This is the equation we're going to plug our vertices in a little bit. Lastly, we have our constraints, our inequalities. So I'm going to try to stay consistent here with my highlighting. Racing skates. What do I know about racing skates? Racing skates require 6 work hours. And let's see. Racing skates. Racing skates require 1 work hour for finishing. Okay. Figure skates require 4 work hours and then 2 work hours. All right. Now we still have this idea of fabricating is 120 and finishing is 40. Okay, so there's a lot of numbers here. So what I'm thinking is I need to write a fabricating one. So the fabricating I can have at most 120, and I have 6 work hours for the racing skates and 4 for the figure skates. So if we have 6R and 4F, that can't exceed 120. Does that make sense? I have my fabricating, so all the fabricating questions I put together. 6 for the racing skates, because that's the number of hours. 4 for the figure skates, and it says no more than, meaning 120 is the maximum, so it could be less than 120. Okay, let's use the same thing and do a finishing one. So the finishing one is 1 hour for racing skates, we'll call that 1R, and 2R for figure skates, we'll call that 2F, and at most 40, so it's going to be the exact same symbol. It's going to be a less than or equal to 40. There's my equation. Okay, so a fabricating one and a finishing one. All right. So next up, we are going to graph it. So it says part E, sketch the feasible region. So here are my two equations. Remember we talked about in class using the x and y intercept slope approach. So if I cover up the f portion, so this is gone. I have 6r equals 120. Well, then r equals 20. If I cover up the r equation, I have 4f equals 120, then f equals 30. So I just jotted those down so I have my intercepts. So what I'm going to do is I'm going to sketch it on my graph. It doesn't matter if you call one R and one F or vice versa. I just did it in order, but it doesn't matter. You will get the same answer as me if you switch your R and your F. So I put R on the X equation and F on the Y axis, and then I labeled it with an appropriate scale based on this 20 and 30. So this means it's going to cross the R scale at 20 and the F scale at 30. So there is my line. All right, let's try the green equation now. So this is my finishing one. So I have 1r plus 2f is less than or equal to 40. So if I cover up the f equation, r is going to be 40. If I cover up the r equation, I get f is 20. Oh, where is it? There it is. Okay, so again, on the r scale, the intercept is 40. On the f scale, the intercept is 20. There is my graph. Okay, so that was part E. Part F asks what are the vertices of the feasible region? So, I guess I haven't finished. I lied. I need to sketch in my shading. So, if I look at this one, 6r plus 4f is less than or equal to 120. So we are going to shade below, I guess I should use blue, below the blue graph. Right? You can do the 0, 0 approach if you'd like. If you plug 0, 0 in, does it work? It does. 0 is in fact less than 120, so 0, 0 gets shaded. If I plug 0, 0 in here, 0 is in fact less than 40, so I'm going to shade below the green one. So everything below green is going to get shaded. So finish off my gorgeous shading. There we go. Now I need to go back and use my eraser because I don't want the stuff that's not overlapping. So it's just this little trapezoid right here. There it is. Okay, so that is my feasible region. There we go, beautiful. Okay. So the vertices of feasible region are, let's see here, right here, right here, right here, and right here. All right, so you'll notice this is a really nice graph, so I don't have to do the plugging in like we did in class yesterday. So I can see pretty obviously where my three vertices are. One is at 20, 0, the next one's at 10, 15, the next one's at 0, 20, and the 0, 0 one, I'm not even going to bother writing it down because I remember the question was a maximize problem. 0, 0 is never going to maximize anything. I'm not even getting my, throwing it in there and trying to get any skates out of that. So, like I said, these were my three vertices. Okay. So what I'm going to do now is I'm going to test these vertices by plugging them in to my objective function. My objective function was how am I going to get a profit again? I'm going to sell, let's see, the skates for $10 and the other skates for $12. So let's see here. There it is. So if I plug R in for 0 and F in for 20, I got 240 here, I got 200 here, and I got 280 here. I'm not going to spend a lot of time on this. You know how to do this. So which one maximize? Remember the question was a maximize. Well, it's the 280 one, right? So that means if I sell 10 of this one and 15 of this one, I will make a profit of 280. So that's what they asked down here. Write your conclusion as a complete sentence. So I wrote, if I make 10 racing skates and 15 figure skates, 10R, 15F, that would maximize my profit to $280 each day. All right, So that was example number 1. Now we're going to go through it all over again. Okay, so this example, I'll read it to you. A stationery company makes 2 types of notebooks, a deluxe notebook with subject dividers, which sells for $1.25, and a regular notebook which sells for 90 cents. The production cost is $1 for each deluxe notebook and 75 cents for each regular notebook. The company has the facilities to manufacture between 2,000 and 3,000 deluxe and between 3,000 and 6,000 regular notebooks, but not more than 7,000 altogether. How many notebooks of each type should be manufactured to maximize the profit? Okay, so again, we structured it for you, so we're going to answer all of these questions together. So it's not just doing this question by yourself. So first off, are we maximizing or minimizing? Well, we are maximizing right there. Okay. The 2 variables. So I'm talking about notebooks. I got a deluxe one and a regular one. So it's okay with you, I'm going to call it D and R. The objective function was, how am I going to profit from selling these notebooks? So there's a little bit of math involved here. Let's see, let me go to my highlighter. All right, so if I have my my deluxe notebook, so we'll make deluxe yellow. The deluxe notebook sells for $1.25, but it costs $1 to make. So that means every time my profit is 25 cents. Not that great a profit. All right, my regular notebook sells for 90 cents. And let's see, cost is 75 cents. So that means I'm making a profit of 15 cents. So all I'm doing here is I'm just subtracting. 90 minus 75, $1.25 minus $1. So because profit is how much you take in minus how much it costs you to make it, right? So my profit is if I can sell a bunch of deluxe and a bunch of regular notebooks. So I'm going to go 0.25 times D. That's my profit on deluxe, plus 0.15, that's my profit on regulars, times R. Okay. Next up is my constraints and my inequalities. So let's try this. Let's see. So it can manufacture between 2,000 and 3,000 deluxe. Okay, so that's one equation. Can go between 3,000 and 6,000 regulars. And running out of colors, not more than 7,000 together. Okay, so what that means is the first one, the D, is going to be between 2,000 and 3,000. The R is going to be between 3,000 and 6,000. But then together, that means D plus R is going to be less than or equal to 7,000. Well, my equations are not going to show up. Okay, they're on the next page though, so let me show you. There. Okay, so D was between 2,000 and 3,000. My R was between 3,000 and 6,000. But together, meaning plus, I can't have any more than 7,000. So those are my 3 constraints, my inequalities. So let's sketch the feasible region. So this one is actually really nice because I put D on the X scale, R on the Y scale. Again, you could switch it, doesn't matter. So that means on D, it's going to be between 2,000 and 3,000. There it is. Okay. My R was this way, so it's between 3,000 and 6,000. There it is. And then D plus R equals 7,000. So if I do the intercept method, if I cover up R, that means D is 7,000. If I cover up D, that means R is 7,000. So over here at 7,000 all the way till 7,000 on this scale, I'm going to get my line. Okay, so now I need to highlight. Well, the green one's pretty obvious. It's got to be between these two, right? So it's this section in here. The blue one, same thing, got to be between these two. Oh, this is gorgeous. Wow. Okay, and then the purple one, if I plugged in 0, 0, right? 0, is that less than or equal to 7,000? It is. So I'm going to shade below the purple line. Okay, so let's see how gorgeous this is. I'm going to erase anything that doesn't overlap between all 3 of them. So I get this gorgeous region in here. There it is. You see it? It's a little trapezoid. Okay. So the vertices, there's 4 of them. So I have 2,000, 3,000 right there. 3,000 comma 3,000, 3,000 comma 4,000, and 2,000 comma 5,000. 4 corners. Let's see what I got there. There they are. Whew. Those are my 4 corners. So almost there, the last step, we are going to test the vertices in our objective function. So here's my objective function again, it's my profit function. So I'm going to go 2,000 times 0.25 plus 3,000 times 0.1r. Okay, so I will do that for all 4 of them. And I did it ahead of time to save some time because this video is very long. These were my 4 answers. You should certainly double check me. Now, if you remember what the objective was, it was to maximize. So that's this guy right here, the 3,000, 4,000. So if we write that in a sentence, this is 3,000 of the deluxe and 4,000 of the regular. That's going to get me a profit of this much money. So here's what I wrote. If I make 3,000 deluxe and 4,000 regular notebooks, it would maximize my profit to $1,350 each day. All right, well, thanks for sticking through me on this video, and good luck on your homework, everyone.